Algorithms and Data Structures Guide Introduction. Algorithms and data structures are the foundation of software engineering and coding interviews. A data structure is a way to store and organize data. An algorithm is a step-by-step method to solve a problem. Software engineers use algorithms and data structures for coding interviews, backend development, database indexing, caching, searching, sorting, recommendation systems, routing systems, file systems, compilers, distributed systems, scalable applications. A common learning topic is how can beginners learn algorithms and data structures step by step? This guide explains Big O notation, arrays, strings, hash maps, hash sets, stacks, queues, linked lists, trees, binary search trees, heaps, graphs, recursion, sorting, searching, sliding window, two pointers, dynamic programming, greedy algorithms, Java examples, interview questions, 30-day learning plan. Simple definition, data structure. A data structure answers, how do we store data? Examples: array, hash map, stack, queue, tree, graph, heap, linked list, algorithm. An algorithm answers, how do we solve the problem? Examples: binary search, DFS, BFS, sorting, sliding window, dynamic programming, greedy. Simple idea. Data structure equals storage. Algorithm equals logic. Example: use HashMap to store frequency. Use algorithm to find top k frequent elements. Why algorithms and data structures matter. They help you write code that is faster, cleaner, scalable, interview ready, memory efficient, easier to debug. Example: problem, find duplicate in array. Slow approach. Compare every pair means O of n squared. Better approach. Use HashSet means O of n. This is why data structures matter. Big O notation. Big O tells how performance changes when input size grows. Common complexities. ... Big O meaning example. O1 constant time. Access array index. O log n logarithmic. Binary search. On linear. Loop through array. On log n efficient sorting. Merge sort. On squared nested loops. Brute force pairs. O2 to the n exponential. Sum recursion. On factorial permutations. Big O example. Array text. 1, 2, 3, 4, 5. Access index. Int value equals nums 2. Complexity. O1. Loop through all numbers. For int num nums. System out println num. Complexity. On. Nested loop. For int I equals 0. I less than nums length. I plus plus. For int j equals 0. J less than nums length. System out.println nums I plus plus nums j. Complexity. On squared. Core data structures: array, string, hash map, hash set, stack, queue, linked list, tree, heap, graph, trie. Array stores elements in order. Example: int x nums equals 2, 7, 11, 15. Access. System out.println nums 0. Use arrays for k. Fixed size data. Fast index access. Coding interview problems. Sorting, searching. Two pointers. Sliding window. Complexity. Operation time. Access by index O1. Search On. Insert at end O1. If space. Insert at beginning On. Delete from middle On. Common array problems. To sum. Contains duplicate. Best time to buy and sell stock. Maximum subarray. Product of array except self. Move zeros. Merge sorted array. Rotate array. Array example. Maximum public int find max. Int nums. Int max equals nums 0. For int num nums. If num is max, max equals num. Return max. Complexity, time, on, space, 01, 2, string. String is a sequence of characters. Example, string name equals Java. Use strings for text processing, validation, parsing, search, anagrams, palindromes, frequency count. Important. In Java, string is immutable. That means when you modify a string, a new string is created. Common string problems: valid anagram, valid palindrome, longest substring without repeating characters, group anagrams, reverse string, first unique character, string compression string example. Reverse string, public string, reverse string input. String builder equals new string builder. For int I equals input.length -1, I equals 0, I -1. Return builder.toString. Complexity, point. Time, on, space, on, 3, HashMap. HashMap stores. Key means value. Example. Map, string, integer. Scores equals new HashMap. Scores.put John 90. Scores.put Mary 85. Access. Int score equals scores.get John. Use HashMap for check frequency count, check lookup, check caching, mapping ID to object, to sum, grouping data. Complexity, average. Operation time, put 01, get 01, contains key 01, remove 01. HashMap example, frequency count. Public map integer, count frequency. Int nums. Map integer, frequency map equals new HashMap. For int nums, frequency map.put num frequency map get or default num 0. Return frequency map. End. Input 1, 1, 1, 2, 2, 3. Output 1 means 3, 2 means 2, 3 means 1, 4. HashSet. HashSet stores unique values. Example. Set integer scene equals new HashSet. Scene.add1, scene.add2, scene.add1. Set contains 1, 2. Use HashSet for check duplicate detection, membership checking, visited nodes, unique values, fast lookup. Common problems. Contains duplicate, longest consecutive sequence, intersection of arrays, graph visited tracking. HashSet example. Contains duplicate, public boolean contains duplicate, int nums. Set integer. Scene equals new HashSet. For int num dot nums. If scene dot contains num, return true. Scene.add num. Return false. Complexity. Time, O of n, space, O of n, 5, stack. Stack follows. Last in, first out. Short form. LIFO. Example. Push 1, push 2, push 3, pop means 3. Java. DQ integer. Stack equals new array deque. Stack.push1, stack.push2, stack.push3. System out println stack.pop. Use stack for cuts, undo operations, cuts, valid parentheses, cuts, DFS, cuts, expression evaluation, cuts, monotonic stack, cuts, browser back button. Stack example, valid parentheses, public boolean is valid, string s. DQ character stack equals new array DQ. For char ch s.toChar array. If ch equals sha, stack push p. Else if ch equals ble, stack push p. Else if ch equals sha, stack push p. If stack is empty or stack pop equals p, return false. Return stack.isEmpty. 6. Q. Q follows. First in, first out. Short form. FIFO. Example. Add 1, add 2, add 3, remove means 1. Java. Q integer, Q equals new array dq, q.offer1, q.offer2, q.offer3, system.out.println, q.poll. 1. Use Q for BFS, task scheduling, message processing, producer-consumer systems, level order traversal. Q example, basic BFS structure, Q integer, Q equals new array dq, q.offer, start node. While any q.is empty, int node equals q.poll. For int neighbor, graph.getNode, q.offer neighbor, end. Linked list stores nodes connected by pointers. 1 means 2, means 3, means null, node. Class list node, int val, list node next, list node int val, this.val equals val. Use linked list for call, pointer practice, reversing list, cycle detection, merging lists, interview questions, common problems. Reverse linked list merge two sorted lists. Linked list cycle remove nth node from end. Middle of linked list example. Reverse list, public list node reverse list. List node previous equals null. List node current equals head. While current equal null. List node next node equals current.next. Current.next equals previous. Previous equals current. Current equals next node. Return previous. Before, 1 means 2 means 3 means null. After, 3 means 2 means 1 means null. 8. Tree. Tree is a hierarchical structure. Example. 10, subsep, 5, 15, 7, 20. Terms. Term meaning. Root. Top node. Child node below another node. Parent node above another node. Leaf node with no children. Height. Longest path down. Subtree. Tree inside tree. Binary tree node. Class tree node. Int val. Tree node left. Tree node right. Tree node int val. This.val equals val. End comma. Tree traversals. Common traversals. In order, pre-order, post-order, level order, in order. Left means root, means right. Public void in order, tree node root. If root equals null, return. In order, root.left. System.out.println root.val. In order, root.right. Pre-order, root means left means right. Post-order, left means right means root. Level order BFS using Q. 9. Binary search tree. Binary search tree rule. Left side, left. Root, right side. Example. 8, 0, 3, 10, OS, 1, 6, 14. Use BST for efficient search, sorted data, insert, delete, search, tree interview problems. Average complexity. Search, O log n. Insert, O log n. Delete, O log n. Worst case. O n. If tree becomes unbalanced. BST search example. Public Boolean search, tree node root, int target. If root equals null, return false. If root.val equals target, return true. If target equals root val, return search root left, target. Return search root.right, target. 10. Heap. Heap is a priority-based data structure. In Java, priority queue integer min heap equals new priority queue, comma, min heap. Smallest value comes first. Max heap. Priority queue integer max heap equals new priority queue a b b minus a. Use heap for C top k problems, C kth largest, C priority scheduling, C merge k sorted lists, C shortest path algorithms. Heap example. Kth largest, public int find kth largest, int nums, int k. Priority queue integer, min heap equals new priority queue can. For int nums, min heap dot offer, If minheap.size equals k, minheap.pol, return minheap, peak. Complexity. Time, on log k, space ok, 11, graph. Graph contains nodes plus edges. Example, A double B, C double D. Use graphs for dot, key social networks, maps, recommendations, dependency graphs, microservice dependencies, network routing, fraud detection. Graph types. Directed graph, undirected graph, weighted graph, unweighted graph, cyclic graph, acyclic graph, graph representation, adjacency list, map integer, list integer, graph. Graph.put1, list of 2, 3. Graph.put2, list of 1, 4. Graph.put3, list of 1. Graph.put4, list of 2. Visual. 1 means 2, 3 2 means 1, 4 3 means 1, 4 means 2. Graph BFS, public void BFS, map integer, list integer, graph, in start. Set integer visited equals new HashSet. Q integer Q equals new array DQ. Q.offer start. Visited.add start. While np.isEmpty. Int node equals Q pull. System.out.println node. For int neighbor, graph.get or default node list of if visited.contains neighbor, visited.add neighbor, q.offer neighbor, vis.diff public void DFS, map integer, list integer, graph, int node, set integer, visited. If visited.contains node, visited, add node, system.out.println node. 4. Int neighbor, graph.getter default, node list of. DFS graph, neighbor visited. Try is a tree used for prefix search. Use try for check, autocomplete, dictionary search, prefix matching, search suggestions, word problems. Example words: cat, car, care, dog. Try structure: CATREDOG. Common algorithm patterns. 2 pointers, sliding window, binary search, recursion, backtracking, DFS, BFS. Dynamic programming, greedy sorting, prefix sum, union find. 1. 2 pointers. Use 2 pointers when conc. Arrays sorted, need pair search, need reverse, need remove duplicates, need compare from both ends. Example: left means start, right means end. Palindrome check. Public boolean is palindrome string s. Int left equals 0. Int right equals s dot length minus 1. While left and right. If s char at left equals s char at right. Left plus plus, right minus. Return true. 2. Sliding window. Use sliding window for sub-array problems, substring problems, longest, shortest window, fixed window size, variable window size. Example problem: find maximum sum of subarray of size k. Code: public int max sum subarray, int nums, int k, int window sum equals 0. For int I equals 0, I to k, I plus plus, window sum equals nums I. Int max sum equals window sum. For int right equals k, right, nums length, right plus plus, window sum plus plus nums right, window sum minus nums right minus k. Max sum equals math.max, max sum, window sum. Return max sum. Complexity. Time n, space, 01, 3, binary search. Use binary search when data is sorted, answer space is monotonic, need first last valid answer, need O log n search. Code: public int binary search, int add nums, int target. Int left equals 0, int right equals nums got length minus 1. While left equals right. Int mid equals left plus right minus left over 2. If nums mid equals target, return mid. If nums mid equals target, left equals mid plus 1. Else, right equals mid minus 1. Return minus 1. For recursion. Recursion means a function calls itself. Example. Public int factorial, int n. If n equals 0, return 1. Return n factorial n minus 1. Important parts. Base case, recursive call, progress toward base case. Common recursion problems. Tree traversal, DFS, backtracking, subsets, permutations, dynamic programming. 5. Backtracking. Backtracking means try a choice, explore, then undo the choice. Used for yes subsets, yes permutations, yes combinations, yes n queens, yes Sudoku, yes generate parentheses. Example, subsets. Public list, list integer, subsets. List integer result equals new array list. Backtrack, nums 0, new array list app, result. Return result. Private void, backtrack. Int in nums, int index, list integer current, list integer result. If index equals nums length, result.add new array list current, return. Current.add nums index, backtrack, nums index plus 1, current, result. Current.remove current.size minus 1. Backtrack nums index plus 1, current result. Greedy means make the best local choice at each step. Use greedy when local optimal choices lead to global optimal answer. Examples. Jump game, meeting rooms, assign cookies, gas station, activity selection, interval scheduling. Example. Public int max profit, int prices. Int min price equals integer max value. Int max profit equals 0. For int price prices, min price equals math min price price. Max profit equals math max profit price minus min price. Return max profit. 7. Dynamic programming. Dynamic programming is used when check. Problem has overlapping subproblems. Problem has optimal substructure. Recursion repeats same work. Examples. Climbing stairs, house robber, coin change, longest common subsequence, 0,1 knapsack. Decode ways. Simple definition. DP equals remember previous results to avoid recalculation. DP example, climbing stairs. Problem. You can climb 1 or 2 steps. How many ways to reach step n? Code. Public int climb stairs int n. If n equals 2, return n. Int first equals 1. Int second equals 2. 4. Int I equals 3. I equals n, I plus plus. Int third is first plus second. First equals second. Second equals third. Return second. Complexity. Time, O(n). Space, O(1). 8. Sorting algorithms. Common sorting algorithms. Algorithm time notes. Bubble sort, O of n squared, beginner only. Selection sort, O of n squared, simple. Insertion sort, O of n squared, good for small or nearly sorted. Merge sort, O of n log n, stable. Quick sort, O of n log n, average, fast in practice. Heap sort, O of n log n, uses heap. Counting sort, O of n plus k, limited range numbers. In Java, arrays.sort, nums. For list, collections.sort, list. Custom sort. Employees.sort, comparator.comparing, employee : get salary, reversed. Prefix sum helps answer range sum quickly. Array. Nums equals 2, 4, 6, 8. Prefix. Prefix equals 0, 2, 6, 12, 20. Range sum from left to right. Prefix right plus 1 minus prefix left. Java. Public int build prefix sum int nums. int prefix equals new int nums.length plus 1. 4 int I equals 0. I equals nums length I plus plus. Prefix I plus 1 equals prefix I plus nums I. Return prefix. Use for range sum queries, subarray sum, matrix sum, optimization problems. 10. Union find. Union find is used to manage connected components. Use for check graph connectivity, check number of islands, check cycle detection, Trusco algorithm, check friend circles. Basic class. Class union find. Private final int parent. Public union find int size. Parent equals new int size. 4. Int I equals 0. I less than size. I plus plus. Parent I equals I. Public int find int x. If parent x equals x, parent x equals find parent x. Return parent x. Public void union int a int b. Int root a equals find a. Int root b equals find b. If root a is not root b, parent root b is root a. Problem pattern cheat sheet. Problem type common pattern. Find duplicate hash set. Count frequency HashMap. Top k heap bucket. Sorted pair sum. 2 pointers. Subarray/substring. Sliding window. Search sorted array. Binary search. Tree traversal. DFS BFS. Shortest path unweighted. BFS connected components. DFS union find. All combinations backtracking. Optimization repeated subproblem DP. Minimum maximum local choice. Greedy beginner DSA roadmap. Level 1 basics. Learn big O arrays, strings, loops, HashMap, HashSet. Practice. 2 sum contains duplicate valid anagram, first unique character. Level 2 core patterns. Learn 2 pointers, sliding window, stack, queue, binary search. Practice. Valid palindrome, longest substring without repeating characters. Valid parentheses, binary search. Search insert position. Level 3 linked list and trees. Learn linked list, recursion, binary tree, DFS, BFS, BST. Practice. Reverse linked list. Merge 2 sorted lists. Maximum depth of binary tree. Invert binary tree. Validate BST. Level order traversal. Level 4 advanced structures. Learn heap, graph, try, union find, prefix sum. Practice. Top k frequent elements, kth largest element, number of islands, course schedule. Implement try, subarray sum equals k. Level 5 advanced algorithms. Learn backtracking greedy, graph shortest path, graph shortest path. Practice. Subsets, permutations, jump game, climbing stairs, house robber, coin change, longest common subsequence, 30-day learning plan, week 1. Learn big O, arrays, strings, HashMap, HashSet. Practice. 2 sum contains duplicate, valid anagram, group anagrams, top k frequent elements, week 2 patterns. Learn 2 pointers, sliding window, stack, queue, binary search. Practice. Valid palindrome, 3 sum, longest substring without repeating characters, valid parentheses, binary search, week 3, linked list, trees, graphs. Learn linked list, recursion, tree DFS, tree BFS, graph BFS DFS. Practice. Reverse linked list. Linked list cycle, maximum depth of binary tree. Invert binary tree, number of islands, course schedule week 4, advanced DSA. Learn heap, backtracking, greedy, dynamic programming, union find. Practice. Kth largest element, subsets, combination sum, jump game, climbing stairs, house robber, coin change, common beginner mistakes. 1. Memorizing solutions without patterns. Bad. I memorized 50 problems. Better. I understand 10 patterns and can apply them. 2. Ignoring big O. Bad. My code works for small input, so it is fine. Better. Check time and space complexity. 3. Using wrong data structure. Example, need fast lookup, but using list contains. Bad. List.contains value /on. Better. Set contains value O1 average 4. Not testing edge cases. Always test. Empty input. One element duplicates. Negative numbers, sorted input, unsorted input, large input, null if applicable. 5. Not doing dry run. Before coding. Do. Input expected output steps, variables, state changes. 6. Not explaining approach. In interviews, do not silently code. Explain. Brute force, optimized idea, data structure complexity, edge cases, best practices. Earn. Patterns. Not only problems. Always start with brute force. Then optimize. Choose the right data structure. Write clean Java code. Do dry runs. Test edge cases. Explain time complexity. Explain space complexity. Practice daily. Review mistakes. Group problems by pattern. Write unit tests. When possible. Use diagrams for trees/graphs. Use HashMap for frequency. Use HashSet for duplicate visited. Use queue for BFS. Use stack recursion for DFS. Use priority queue for top K. Interview, problem, solving, template. Use this structure. 1. Clarify the problem. 2. Give example. 3. Explain brute force. 4. Explain optimized approach. 5. Choose data structure. 6. Write code. 7. Dry run. 8. Analyze complexity. 9. Mention edge cases. Example explanation. I can solve this using a hash map. First, I count frequencies. Then I use bucket sort to collect top K frequent elements. This gives O of n time and O of n space. Must know Java classes for DSA. Java class use, int, arrays, string text, string builder, efficient string building, array list, dynamic array, hash map, key value lookup, hash set, unique values, array-deque, stack queue, priority queue, heap, arrays, sorting helpers collections, list utilities, comparator, custom sorting, common Java DSA. Snippets hash map, frequency map, integer, map equals new hash map. For int nums, if scene.contains num, return true. Scene.add num. Priority queue min heap. Priority queue integer min heap equals new priority queue open. Priority queue max heap. Priority queue integer max heap equals new priority queue AB. B minus A. Q integer. Q is new array deque. Q offer 1. Int value equals q.pull. Stack deque integer. Stack equals new array deque. Stack push 1. Int value equals stack pop. Top interview questions by topic. Arrays to sum. Contains duplicate product of array, except self. Maximum subarray. Best time to buy and sell stock. Strings, valid anagram, valid palindrome, group anagrams. Longest substring without repeating characters. Stack, valid parentheses. Min stack. Daily temperatures. Evaluate reverse Polish notation. Binary search. Binary search. Search insert position. Search in rotated sorted array. Find minimum in rotated sorted array. Linked list. Reverse linked list. Merge two sorted lists. Cycle. Remove nth node from entries. Maximum depth of binary tree. Invert binary tree. Validate BST. Level order traversal. Lowest common ancestor. Graphs. Number of islands. Clone graph. Course schedule. Pacific Atlantic water flow. Dynamic programming. Climbing stairs. House robber. Coin change. Longest increasing subsequence. Longest common subsequence. Real-world use cases. Backend development. HashMap means cache lookup. Queue means background jobs. Stack means undo action history. Tree means hierarchical categories. Graph means service dependencies. Heap means priority tasks. Databases B-tree indexes, hash indexes, query optimization. Sorting, search cloud-native systems. Queue for async jobs. Graph for microservice dependencies. Hashing for partitioning. Heap for priority scheduling. Cache with HashMap-like lookup. Search systems. Try for autocomplete. Heap for ranking. Graph for recommendations. HashMap for indexing. 90-day DSA roadmap. Month 1, beginner. Focus. Arrays, strings. HashMap. HashSet. Sorting, binary search. Goal. Solve 40 easy problems. Month 2, intermediate. Focus. Cache, queue, linked, text, trees, recursion, sliding window, 2 pointers. Goal. Solve 40 easy medium problems. Month 3, advanced. Focus. Heap. Graph. Backtracking. Greedy. Dynamic programming. Union find. Goal. Solve 40 medium problems. Final summary. Algorithms and data structures are essential for software engineering and coding interviews. Important data structures. Array, string, HashMap, HashSet, stack, queue, linked list, tree, heap, graph, try. Important algorithms and patterns. Callus, big O, sorting, binary search, 2 pointers, sliding window, recursion, backtracking, BFS, DFS, greedy, dynamic programming, union find, prefix sum. Key idea. Learn patterns first, then solve problems using the right data structure. For interviews, do not only write code, explain approach, complexity, edge cases, and dry run.